All right, good afternoon. Um, Things that I want to go over with before going to the lecture is the project proposals. So if you go to the project proposals site, um, what I'm asking you to do is today send me an email, and in that email, make a choice of one of these projects here that I'll go over with just a second. And just tell me what's your favorite project. You can tell me what's your next favorite and your third favorite as well if you like. Tell me as many choices as you like. And I'll try to accommodate as many of you as I can. So what I'm going to do is I'm going to be getting emails from everyone. And then if there is exactly 3 or 4 people who want to do a particular project, then I will let them put them together and let them do that, or I'll make whatever tweaks I need to do to make everything come out okay. So give me whatever information you have. Actually, in the interest of, because we have somehow a week less than the students had last semester on these, what I'll be doing is I might say, okay, you guys are going to do the first project, and I'll say, but only do class diagrams, or only do sequence diagrams. So all of those projects involve with making some modifications to the code base of the Violet UML editor that you now know and love. And so in the first one, if that's the one that you choose, this would be involved in using JavaFX, which is a more modern Java desktop user interface toolkit. I would give you out some information about how to program in JavaFX. It is not wildly different from programming in Swing. It's just the classes have slightly different names. The way that you do event handling is slightly different. There's one big difference in JavaFX that should make it actually quite a bit easier, and that is in JavaFX you can say, I want to have a certain shape, like a rectangle or something, or an arrow, and that shape is an object, and you can move it around, you can manipulate it, and so whoever takes on the FX Violet project, what I would want them to do is to take on the base of what's currently in Violet and take advantage of that wrinkle of JavaFX. I had some people doing that in a previous semester, and they didn't take any advantage of it, and so that seemed kind of pointless. We are going to be going into a couple of lectures on Android programming next week, and the rationale for that is that you've been learning a lot about Swing user interfaces, and it has 0 resume value at this point. So I wanted to show you how what you've learned translated to doing some Android programming. So if you like to do that, if you want to dig deeper into that, or if you already have some prior experience with it, this kind of project might be for you, where you would figure out some way on how one does UML diagrams on your phone or tablet. This works particularly if you actually have an Android phone or tablet. If you're an iPhone user, you probably want to stay away from this one. The next project is interesting and useful, and it's something that people have tried to do commercially for some time, where the idea is normally you draw your UML diagrams, and then you start doing your project, and whatever it is that you're building, and eventually the diagrams and the code get out of sync, because the code evolves, and who is ever in their right mind going to take the time to update the diagrams? It just doesn't happen. And so if you think about what makes JavaDoc work, in JavaDoc you put the specification for the documentation right into the code. And so can one do something similar? And yes, one can. There's a thing called annotations that makes that possible. And so what you would then do is make it so that Violet can read those annotations and redraw the diagrams. Another project that's kind of fun, and that's going to be picking up on the code that on the lab that we're doing today, is imagine you have multiple users that all want to collaboratively work on a diagram. Say that you're all on a conference call, and now one person makes an annotation and the other one wants to make an annotation as well, and you want to kind of see the same thing, just like when you're simultaneously editing a Google document, for example, or a Google spreadsheet. And so that turns out is not as hard to implement as you might think. You need to know just a little bit about sending stuff to a server and querying the server what was sent to it. And there is a pattern actually that supports that called the command pattern. Another one that you might find interesting is, especially if you've tried some of these alternative ways of making UML diagrams that use text descriptions, to graft that onto Violet. So have a look at those. This is particularly useful for sequence diagrams. Sequence diagrams, if you think about it, it is kind of stupid to draw these arrows back and forth when you could just write down who calls what. And then the sequence diagram ought to be deduced from that. And finally, another application of the command pattern that's not all that hard to do is to implement undo and redo. So the Violet version that we have doesn't have it. There's a professional version of Violet that has a different way of doing undo and redo. But here the idea is to just use the command pattern and put it to the regular one. So pick the one that you think has the best resume value or interest. You're going to be living with this project for the next 5 to 6 weeks. So you might as well pick something that you like. Send me an email and say, this is my favorite project. If I don't get that, then maybe these ones would also be okay. But whatever you do, don't assign me X. And then I have an idea of what your preferences are. If you have any preferred teammates, by all means, let me know who you would like to work with. No promises that I will accommodate that. I will then, by Wednesday morning, have set up all the projects. And what I'll probably simply do is I will put on this web page the names of everyone. And then I'll send each of the project teams an email with all the emails of the team members. So make sure that you send me your email from the email address that you want everyone else to know. Because of course the team members have a way of communicating with each other. So looking at the calendar, within a week, the team will need to have accomplished something. I think that's true. Let me double check here. So there's a homework on Sunday. Yes. So by next Tuesday night, you will all have to submit project reports. Have a quick look at what these reports should look like. It says right here. And by the way, these reports all have to appear on your Bitbucket or GitHub site for the project. So each of the 8 or so teams that we're going to be having will make a Bitbucket or GitHub site, your choice which one of the two you want to use. Add all your team members, add me of course, let me know what that is, and then use the wiki feature to put in your progress reports, your design documentation, and so on. And you use the issue tracker feature of either Bitbucket or GitHub to list, to assign work amongst each other and organize yourselves. Of course, you put all the source code of your project into your Git repo. And what I will periodically do, at least once a week, but probably more often than that, is I will check out your source code and I will build it. For that, you have to give me a build script, some kind of a script that does the build automatically. The source code for Violet has an Ant script. Ant is a tool that automatically builds. And you don't really have to know anything about Ant other than typing the 3 letters A, N, and T. Now you have to install it, but you just run Ant and it automatically builds. If you use something else, like if you do the Android part, then I will show you how to do the build script of that. But it is a requirement that whatever is on GitHub, just builds. So the other thing that you need to do is you need to frequently check code in. What I do at the end of the project, I pretty much simply count as to how many check-ins there were. So if you decide that you only want to check in something once a week, you're free to do that, but your grade will seriously suffer. If you, on the other hand, want to get an A, you should check in every 20 minutes. So whenever something works. I mean, you're constrained by the fact that you can't check it if it breaks the build. But if something works, go ahead and check it in. Your teammates then have the latest and greatest, and that way, whatever, that way you move the project forward. Now, if you have no experience doing this on a team project, people are often nervous. They say, well, gosh, there's 4 people working on this thing. Now, if I check in something, how do I know that I'm not overriding the code from someone else? And as it turns out, it almost never happens that you do. It's kind of surprising that once in a while there's a conflict, and then it's usually an easy matter of resolving it. And the first time it looks scary, but after that you will have learned how to do this. I'm working on a project right now with, I would imagine, literally about 50,000 files, and there's 6 or 7 people working on it, and it's just absolutely amazing to me that we've done this over the last 2 years, and never once was there a situation where someone had to pick up the phone and say, "Hey, there's trouble." Every change where we edited the same file, it was just completely and patently easy for whoever came last to resolve the issue. It was always a trivial thing, and then afterwards everything was fine again. So some people say, well, I should do branching and merging. If you know how to do that, then that's good. Then you also know how not to do it, so just don't. If you branch and merge, I have no easy way of finding out who did what. And it just adds a layer of complexity that's not really useful for a 5-week project. So it says here each team should be prepared to give a brief progress report on Monday. I fixed that. I mean Wednesday. So each Wednesday I will have one team come up that I randomly choose, maybe 2 teams, and say, hey, build the stuff in front of everyone on my machine. And then I will ask a question or 2 about how far you've gone. What's super important is that you work the issue tracker well. So the issue tracker just says there is an issue, and of course you all have one big issue, namely that you want to get the project done. But that issue is too broad. So the issues that you should put on the issue tracker should be short, no more than a day or 2 to get them resolved, and assigned to a single person. And that's another metric that I use to check whether the project is working well, and if all the teammates pitch in, I look at the assigned issues. And if all those issues are short and assigned to a single person, and that single person then clears them soon afterwards, then I know the project is in good shape. If I see no issues, then I know the project's getting no love. Or if I see issues that are all assigned to one person, then I know that the team is not well developed. So teamwork is one of the things that we want to learn in this class to make sure that you get that straight. If you've never used an issue tracker before, it's not difficult. It's pretty straightforward. What is genuinely difficult is to find those issues, particularly at the beginning of the project when you don't quite know. So you should go and assign each other, have a meeting in person or on Skype or whatever way you want to do that on Hangouts. Hash out who's going to do what in the next day or 2, and after a day or 2, then regroup for 15 minutes and see how things are going. This is something, unfortunately, where you have to do this several times a week. If you try to do this only on the weekends, you're not going to be able to get it done. So set that time aside. Find some way that you can organize that. You can meet by email if you really can't find a common ground, or by text messaging, whatever. Everyone in the past has figured out some way of getting it done. The one thing that everyone learns is that every one of you could probably do your assigned project in 3 to 4 weeks, no trouble, alone. But it's actually very hard to do it in a team. That's life. That's something that one has to learn. For a small project, of course, it's much faster to do it alone. But the reason that you're learning this teamwork stuff is so that when you do join the workforce, that you can effectively function in a team. When we survey employers and ask them, what is it that we're failing to teach students? Should we teach them more algorithms or more programming languages or more UML or something? The employers always come back with one thing and say, teach them more teamwork. They don't care about yet another algorithm or yet another programming language, but they greatly care about teamwork. The second most important thing, does anyone know, after teamwork, what the employers ask for? No. Business sense. That you have some idea of how the money flows. So, because in communication, sometimes they ask about communication. And when we ask them, what do you mean with that? Then they usually shut up. Because, how much communication does one need? Usually people who can organize themselves and can code are perfectly fine with communicating. I've been communicating with coders from across the planet and who had no measurable communication skills in terms of they would write elegantly or they but as soon as it came down to code, we were always able to communicate just fine. But what really the teamwork thing, to be able to assign tasks to others to be able to figure out what they were capable of, to merge all of that together. That is hugely important. And so that's something that we really want to practice. And you will find that frustrating, but I think in the end you will find that it's better to be frustrated in a safe setting like in a class than when you're on the job. All right, so that's all I want to say about that. We'll regroup on Wednesday and then get that going. So in terms of homeworks, so I have one more homework that's kind of a homework 8 that's kind of somewhat challenging. I don't think quite as challenging as homework 6 was. And that's to make you familiar with more of the code base of Violet on how you do some very basic things with it. And afterwards, I left a couple of slots for homeworks because when I did this last semester, people oddly complained and they said they would have liked to have some more homework on the later sections. And so I'll see. If everyone is humming along great with the project, then I will fill in some easy homeworks, kind of like we had in homework 7 for that. And if, on the other hand, everyone is bogged down with the project, I may not do that. So I've left these placeholders so that I can use them or not. So like I said, the project, it's a little, the time is a little shorter because of spring break. Maybe I should have started before spring break, but I thought that was cruel too, so I did. All right, enough of that. So let's get going with today's lecture. You'll notice that I have swapped chapters 8 and 7, and that is again so to get you going with the material for the project. I don't think it's going to be a big issue. Okay, so that's the lab. I don't want that. There we go. All right, so we're going to be talking about frameworks. So a framework is a key idea of the course. It's a set of cooperating classes that let you build something and that help you build something sophisticated. So for example, Swing is a framework for GUI programming. If Swing was not there, you could write a GUI program, but you would have to know an awful lot about mouse hand, low-level mouse events and keyboards and pixels and stuff. When I was young, that's how we programmed graphical user interfaces. We just did it at a very low level, turning individual pixels on and off, listening to individual keys going up and down and stuff, and it was a lot of work. So now a framework such as Swing bundles all of that knowledge up in a way that makes it easy for you to do this particular problem domain. So a framework is something that's completely different from a design pattern. The design pattern tells you how to organize your own code. A framework bundles up a bunch of existing code, and it leaves you a much smaller surface to deal with. Of course, the framework is usually built with a lot of design patterns. As you've seen, Swing has in its construction dozens of design patterns that were used in there. There's this particular kind of frameworks called application frameworks, and that's a framework that's made for making a complete application. So Swing is an application framework. It's there to make things that start off the command line that you can run by saying Java something. And whereas there are other frameworks that you could imagine a framework, for example, for doing cryptography, for encrypting and decrypting things with certain algorithms, that is going to be a part of an application, but not the whole application. So an application framework is, so what's characteristic of an application framework is that the application is really controlled by the framework. The execution flow is not something that you, the programmer, worry about. You just worry about reacting to events. So for example, in Swing, okay, you do start up in main, you start up something, but then main exits after the initial frame has been displayed, and afterwards, you're no longer in control at all. You can't ask the user, first tell me this, then tell me that, then tell me that. Everything that you code in a graphical user interface application is a reaction to something. The user clicks the button, the user moves the slider, the user does this, And in whichever order the users want to do that, you're pretty much forced to react to that. So that phenomenon is called inversion of control. The framework controls what happens, and then you just are called once in a while and say, hey, this thing happened. What do you think of that? So I thought I'd give you one simple example of a framework that you can completely understand how it's put together, and that's something that you've already used. So you know about JUnit. JUnit is a framework. But it's kind of mysterious, right? It has these annotations and stuff. But why do I say it's a framework? It's there for a specific purpose, for doing unit tests. It provides you with a bunch of functionality that you would not like to do yourself. So for example, all of the reporting when tests fail. You didn't have to do any of that. That's baked into JUnit. You can just use JUnit and you get its standard reporting. There are also hooks, if you don't like the standard reporting, that you can customize the reporting. You want the reporting to go into XML files, you can look into the JUnit documentation, and somewhere there are event listeners that will notify you whenever a new test case has run, and then you can mess with that and route that place anywhere you want. You want colorful green bars, then that's also something that you can add on. And for example, Eclipse has added that on, right? All of that green bar, red bar stuff, that's something that they added on to JUnit by using that part of the framework. Inversion of control is very obvious. This test case has no main. There must be a main somewhere. That main must be sitting here somewhere in work.junit.runner.junit core, but we don't ever see it. So we, the users of this framework, are not concerned with main at all. We're just sitting there and putting our stuff there to be called in the right order. So in the next slides, I'm going to put you together another way of building a unit test framework, not because you will ever use this particular one, but just to give you an idea of how one might go about and design a framework. So JUnit uses these annotations that you've never learned about and you don't really know how to process. So instead, I'm going to use a mechanism that you do know about, namely inheritance. Let's say that rather than annotating the methods for the test with add test, we will put each method in a separate class. So, and that class here, I call it test case. And, so the class should extend test case. So, what I would do for this one here, I would make one class to hold this method and a separate class to hold that method. Now you might say that's more work, and that's true. That's of course why they chose the annotation-based approach in JUnit. But if you didn't have annotations, there would be a viable approach. So that's what we're going to do. So every test case sits in a class that extends this abstract class, and it's put into this execute method. That way, my framework will know how to call the method. It's always called execute. Whereas over here, JUnit had to do the thing of going through this class and somehow finding the annotation, which we don't know how to do. So here's my test runner. This is a part of my framework where I have an array of test cases. For each of the test cases, which is a separate class, that is a subclass of test case, I just call execute. And then presumably execute will call things like with the assert that set flags when something went wrong, or maybe they threw an exception or whatever. And so either way, I can report success or I can report failure, and I have not indicated on the slide how I'm doing that. So here's the way that I am in fact doing that. That I will provide some methods like assert equals, assert this, assert that. And if the assertion fails, then I will throw a test exception. And this one here just happens to have a string. If I wanted more reporting, an exception is a class. I could put anything that I want in the class. I could put a counter for this or for that, and then I could harvest it later. So finally, I'm making a class test suite. And a test suite has a method test cases that is abstract, so one would need to override it. That just gives me the array of test cases that I want to run. And I'll show you in a minute how that gets overridden by a user. And then I provide this run method here. That that I did show. The run method basically contains this. And now I have one technical problem, and that is, let me actually show you the test suite. So here I have a test suite that contains two test cases, the test add and test add negative. This was from the day class from a long time ago. And the day test suite extends test suite. We're overriding get test cases. That's the only method that we did need to override from this abstract class. You see here. So we're overriding it to give us these two classes here. Let's look at one of the classes. Implements test case. Its execute method has that test case that we had weeks ago when we did this with plain JUnit. We're doing something with days, and then we assert that something is equal. I don't care about the details here right now. Note that this assert equals was defined in test cases. My assert equal, not the one from JUnit. So now I want to get day test suite to run. And now I have a technical problem. I cannot say Java space day test suite because this thing doesn't have a main. So I have to have some way of having the generic runner, since I want inversion of control, I want to call the generic runner and say, hey, you execute day test suite. And you have not yet seen how to do that because that's in the chapter that we skipped over. And so I'll show you quickly how to do it, and then we'll get back to that in a week or so. So here's the runner, the test runner. This is the code that's not the programmer who wants to do testing, right? So this is the code that I wrote as the framework provider. It has a main. And it goes through the args that were passed in on the command line, such as, where's the command down here? Such as day test suite. And now it needs to locate that class, and that's the thing that you haven't seen. It uses a mechanism called reflection. There's a method called class.forName that when you give it a string, then it finds the class with that name. And then I need to make an instance of that class, and that's what this thing does over here. And now I have a regular old Java class loaded into memory. And now I can just call run on it, and then everything else is automatic. So when you look at this code and you run it in the comfort of your home, you'll see it's kind of like JUnit. It's a little bit more cumbersome because the user of this class just has to do a little bit more work, has to make a class for each test case, not a single function, and then has to gather them all up in this array. But it's not terrible. In C++, things like that happen all the time. So where you don't have useful things like annotations, people would resort to something like that. And so it shows that with fairly little effort, one can make a framework that embodies, in this case, what? Let's see what benefits this framework conveys over just writing the test cases. In fact, you could just write a thing and put this one into public static void main. But the advantage that we have is two things. Number one is that all of the results get collected together. And that's what happens in JUnit, right? I run JUnit on your homework, and I get this little report that says ... .e ... And then I know exactly, let's look at one place, what passed, what failed. The other thing where JUnit actually adds a tremendous value is it catches exceptions. That every time there's an exception, JUnit catches it, and it keeps on rolling. If you write test cases by hand, it might be that there's an exception in the first test case, and then the second one never gets executed because your entire program was killed. And so those are really, JUnit is not a very fancy framework. It does those services, and my mini JUnit here does the same thing. So when designing a framework, you have to kind of think, what are the obligations that I'm going to put on the user? What are the services that I'm willing to provide for that user? It's a much more complex design decision than it is to design a simple application. So the other framework that I briefly wanted to talk about is the collections framework. This is something you all know from your 46B course. Java has this collection framework. There are different kinds of sets and lists. And so you have a superclass collection. Then there's two sub-interfaces, really. This super interface collection, this sub-interfaces set for unordered collections, lists for ordered collections. Then you have array lists and linked lists of both ordered collections, and then a hash set is this kind of set, and a tree set is, in fact, implements this other interface for sorted traversal. And so whatever. So there is an interface type that has a whole bunch of methods that every collection has to have, where you can add an element, remove all of the elements, check for containment, check for quality, get an iterator to visit all of the elements, remove elements, and so on. And so that's what whoever designed this framework 15 years ago, so what they decided, every collection has to have that. And these are clearly useful methods. So they came up with this iteration strategy that you're now quite familiar with. I'm going to skip this thing because I don't care. Read that book. So the point that I want to make is, this is something that you've probably never done, because for almost all practical purposes, when we use the Java collections, we don't really use it as a framework. The Java collections are so complete that just about any collection that you might ever want to use is already there. I mean, there's sets and maps and the different kinds of them if you need thread safety, for example. But it actually has been designed for a use case where anyone who wants to can add new classes to it. So if you had some other collection that had so far never been seen by humankind, you can add it to this framework. The Java designers did that because in the first version of it, in Java 1.2, it was far more meager than it is now. In particular, all the collections for, that do thread safety did not exist at the time. And they knew that. They said, we better make this so that other people can add new classes to this framework. So collections are an example of a framework that is open-ended on purpose, that gives mechanisms to extend it, but it's not an application framework. It's that you use collections to build your own applications, but the collection framework, it doesn't have a main. It doesn't do inversion of control. It's just a framework for the problem domain of how do you make sensible collections. And so I'll give you this one example on how you can enhance the collections framework. Oops, oh, I thought I did. Let's see, I should have it in Eclipse then. So somewhere in chapter, I don't remember where, 2, yes, there was a bounded Q class that was used to store mail messages. And it's a generally useful mechanism. So a bounded queue is just like the kind of linked list queue that you've seen in your data structures course, except it's backed by an array. Somewhere down here we'll see the array. So it's backed by this array. And it can fill up. Now you might say, why would you ever want a queue to fill up instead of just growing on demand? That actually turns out to be useful when you do concurrent programming. You can make it so that some parts of your program then have to wait until other parts catch up with it. We'll get into that when we go into chapter 9. So here's the implementation at any rate, and so there's a method for looking at the head element, for adding elements, for checking whether it's full, for removing an element, and that's all boring. But notice that it extends abstract collection, which in turn implements collection. And so if you have any method at all that takes a collection, a Java util collection, then you can pass it this bounded queue and it'll also work. The only place where I had to labor a little bit to make this work is I had to implement the iterator method. That's one of the interfaces in collection. And iterator returns a java.util.iterator, warts and all. And so I had to figure out how to get this next and remove stuff to work. And if you remember in homework, what homework 5, 6, somewhere where you had to do the same thing. That is generally tricky, except I cheated out here, and my remove throws an unsupported operation exception. Because for a queue, it doesn't make sense to remove in the middle. The whole point of a queue is you can only remove at one end. So that was easy. Anyway, the point that I wanted to make here is that it is pretty easy to fit something into the standard framework by using the classes that are there and using inheritance. And so that's actually another kind of trivial remark, is that inheritance is what makes frameworks tick. Because the framework provides classes, and your job as the user of the framework is to form subclasses of those classes. That's almost always true. JUnit is kind of the odd man out, because when you use JUnit, you don't actually extend anything. You use these annotations instead. And so it would be kind of interesting to also talk about annotations, but unfortunately, that's not happening this semester. Except for those of you who choose to do the round-trip violet project, I will give you some extra information about it so that you can use them effectively. And then you can tell us all in your presentation. All right, so that's all I want to talk about. Here's other stuff that we don't really need. On Wednesday, we're going to be getting into this graph editor framework. So please go ahead and run those programs in the comfort of your home before you get here so that you're familiar with what the basic things are. There's a lot of fiddly detail, and you need it for the project. So now I want to move on and give you about a half hour to work on the play framework. Just figure out how to get Chrome. How do you get Chrome out of full screen mode? I tried escape. Coke bottle escape. Yeah, try F11 too. Control Command F. Yes, thank you. Of course, yes, that's what makes the Macintosh always so intuitive. Here. Nope. Slides. Yeah. Yes. So I hope enough of you have managed to get through this preparatory part that everyone can buddy up with someone where this works. So let's try that. You guys find a buddy who's gotten this to work. Afterwards, I can make the rounds and troubleshoot the ones who couldn't get it to work. It's not super important outside this lab that it works for everyone, but it would be nice because there should really be nothing particular about it. So go ahead and and run this thing, and then you're going to be building an app that one could use to do those clicker problems that we sometimes do, right? So I say, this is clicker question 1, give me your choice for A, B, C, or D. And in the olden days, of course, you would have done a web user interface, right? A user interface that has like HTML and stuff on it that gets sent the way the server sends a bunch of HTML pages with buttons. And that's how web interface was done in the 1990s. Now it's 2017. No one does that. So nowadays, all web interfaces are written in JavaScript, which unfortunately we don't know how to do, or haven't learned in this course at any rate. But so we're just going to do the part that the JavaScript app would do if you clicked a button. Because what happens is when you click a button in the JavaScript app that runs in your browser, what's it going to do? I mean, it still makes a web request. And that web request just, the way it works in JavaScript typically is that the data is JavaScript data, and then you get JavaScript data back. But you can do it with plain text, even in a JavaScript application. So we're going to be doing it with plain text today. So you're going to be making a request where in the request we put in all of the data that's needed to figure out what's going on. So here we're saying that this particular user selected lesson 16 Q1 and selected the answer C. And we just encode that in the request. When the server gets that, then the server, of course, wants to jack up a counter and say, there's another one who thought that the correct answer was C for the question with ID lesson 16 Q1. And so that's what you're going to be implementing to get that all to work. And you'll be able to do that knowing nothing how a web application works because the framework's taking care of all of the details. All right, so let's get going with that, and you'll undoubtedly get stuck somewhere, and then we'll compare notes and rescue everyone. Yes?
You should be no problem making these steps. But I have a problem. He said we should be fine. He says as long as we finish the presentation, should be fine. Because that's what he told me while I was in his office hour. Yeah. I just tried to go one step. Yeah. And also, which framework, as long as you can see this, something like this, if you can see this page, you'll be fine. Yeah, we're running terminal and you go to this page, you can show something. I don't know why I said that. That's what I asked. That's what I asked. I mean, before going to this step, you should be show something else. I mean, at least my server is able to run. I get all the you run, it is like it takes a while. The first one is yeah. Yeah, it takes a long time. Yeah, you see, because you cannot import you cannot import in the same folder. You cannot import if you set your workspace lab 16. You cannot do. You need, yes, yeah, you just set it as the folder imported. Yeah, it takes forever. I don't know why it's so slow, and also it shows that like it says I don't know the JS. So it says I do not know JS, so they use other stuff for it. You see, that's what. If you go to the app, if you I have all this stuff like probably try to. Yeah, I import all the stuff. Not really, because what I do is, yeah, what I do is like I click import, and I go to exist project into workspace, and I click next, and I set it into lab 16. Yeah, just lab 16. You will see there is exist project here. It's called Playground, and you just import it. And that's all. You probably do some extra work. Yeah. That's you like what I get for it's so slow. Because before I used other server like no, like something like this one, and they also create a local host for you, but it's much faster. It's not slow like this. This one is like pretty slow. Yeah, this one is. So yeah, so next step I'm trying to figure out is try to add a big entry if he doesn't anything else. Make an entry in the config provide handle method. That's he talking about. I mean, this is a handle method. That's it's taken yeah, just because it seems the Eclipse will try to like sync it with your automatic. Essentially, like that's how it sets it. So once you stop, you're gonna set it up, and then you this is like the question. So I say let's say like I say C, then A, right? The C, then D. So it's gonna say like everybody. And then if you say because it's supposed to respond like how many Even in the just leave it there because yeah, so just leave it there. Yes, you can maybe stop and send to GitHub. Yeah, so that's what he says for the next step. He wants us to go to yeah, if you server is running, I go to your locals and yeah, it's like my experience is so slow. Probably, yeah, I got a well confirmation that this time. Yeah, it's kind of like guideline or something. Yeah, something like this, right? If you get this, I think it will be pretty good. That's what he taught me. So what he said is you have to make a note for this one. So but everybody can make it. Yeah, make it. So he said that the guideline should be there. If you go to this page, it teach you how to make it. He said the sample should be which one? Should be something like this. Roll the spell syntax. This configuration guideline. So it seems like we need to make an entry in the configuration field. I don't know, something like yeah, yeah. This is kind of method he already provided. So you can find your roles here. Something like this. He says choose something different. I have no idea how to do it. Yes, that's his part. That's what I think the first maybe a little fast one. It should not be easy. I mean, that's what. Yeah, because the second one is the other stuff, and the other stuff, single other stuff, it's hard. Maybe because the first time loading, I already know it. But I have no idea so I get trouble that's not as hard as and this one is much simpler. Yeah, yeah, but they're not yeah, it's there. It's yes, I think so. That's what I think. But it shows an error there. I don't know why it shows like that. But I have no idea because this one is the code already existing, so I have no idea why it has an error there. It's weird because this stuff is what I had. This stuff is already. It should be fine. Yeah. Why this part shows an error there? Because this one is the code that exists in the yeah.
Oh yeah, it does that. You can ignore it. Does that because index is a template that hasn't been compiled, or Eclipse doesn't know about it.
Oh, so what is the compile doesn't
Eclipse doesn't actually compile it.
Oh, okay.
So you're just using Eclipse.
Okay, so we're just using Eclipse as an editor.
Yes, yes. Whenever you save the file, and the backend runs the saved file, it's going to compile it.
Oh, I see. Okay. So we're okay, I see. So we just use it as an editor. Also, okay. It's fine. So the problem is not yeah. Yeah, this one you can find. This page you can find from the top. You can find from this. So,
I don't think everyone else is there, but let me get to that. Oh, have you met? Okay, which file? Project plugins SPT. So you see how I'm running SPT Eclipse here? Did you do that part? You did? And then after that, yeah, so now all right, so while it's doing this part here, let me go over. So probably most of you got to this point where I'm asking you to make a change to the route file, and then some of you must have gotten stuck with how to do that.
Yes.
So, so this is what you do: is you stare at the syntax here, and we'll find what looks like a good example down here. So here it says dynamic path. So if you look at this one here where it says get client's ID, so it calls some method. Here it's controllers.clients.show. For us it'll be whatever we call the method. And now you notice how the parameters work. So in this case they have one parameter called ID, and the colon indicates that it's a parameter, as opposed to here the clients, which is the fixed string clients. So we have strings where it says slash, what was it, select? Was it select? Okay, slash select, slash problem, slash choice, right? So what you then need to do is slash select, slash colon problem to indicate that that's the variable part, slash colon choice to indicate that that's the variable part. And then in the method, what was the method? Controllers. What's it? Home controller dot select, and then when you make the parameters, you have to also do it in this notation where you do problem colon and I guess string.
For strings, you don't have to put the type.
Okay, but you could. Yeah, and then comma and then choice colon string again, or you can just omit those because it is true that the type is defaults to string. And so it's it's just the syntax that they use, and it's usually when you have to explore a new framework, it's easiest to explore this by example. Everyone has their own way of doing this. So this is the way that the routing happens to work and play. I mean, I've seen 5 other ways of doing it in other frameworks. And once you have that, then you should see sweet success. I'll hook it up in a minute to show you what it's supposed to look like. Okay.
Should be something defined, like so. So you get that's the result.
Select. Oh, because I'm running it. Select as a controller to home controller. Oh, it doesn't save.
The controllers remain
Yeah.
the same. If we supply the RP home controller, right? Right? I guess. And dot show. Oh, the new method we added is select. What's the like ID long no.
All right, so this is what I got when I hooked it up. So here's what I did to do the hooking up. I I pasted in the select method into the home controller, which was in some package controllers. Then in routes, I just invoked it. Oops. I so it's get slash select slash colon problem colon choice, and then it is called controllers home controller select with.
Yeah, I don't get the left side.
What it says so get means it's an HTTP GET request. Then that's the URL pattern. Starts with select, then it has a problem, then it has the choice as variables. The colons mean variables.
I mean, which one is client? Which one is ID?
Oh, what?
Because in the
Why client?
I don't know because we're just trying to.
Oh, that was just the example.
Oh, okay.
Where was it?
So what's the meaning for the clients?
Oh, I have no idea. I mean, that's just whatever they had in the example. So we call it /select, and they wanted to call it /clients. That was a query they wanted to make.
Okay.
I mean, I don't know who would have clients and buy something like that. That's the call that they wanted to make. So our call is not /clients, but /select. It's just a parameterized call. It has a name, and it has some parameter.
Okay.
And that's what you do in a web request. You have to smush it all together. In web request, all you have is a URL.
Yes.
So you have to put together the name of the function that you want to call and all of the parameters with a bunch of slashes in between. And so this thing translates from the world of the web to the world of Java or Scala here.
So do we create the handler method? We didn't talk about that.
Do you create a
One
handler?
of the instructions says create a handler method.
Well, this is the handler, the one, I mean, I've given it to you.
Oh, okay, okay. I thought we were okay.
No. The handler method is
The select.
the select method.
Okay, that's it.
So now the next question is going to be that you have to implement some other service to find out how many of them have been selected. For that, you do need a different handler. So I'll do this really quickly. We don't have a database in here. My database is this little hash map. Gosh, man, this thing is so small. This code here increments the right counter. Terrible. So now this one here, that's another handler, the view method here. So now we just want to see for this map. So what was this map results? Get. Problem. I think I need to turn it to a string. And so now again, to reach this method, I have to put something into routes. This was now view. So it's get view :problem, and now I'm mapping it to controllers, home controller dot view, and that's it. So let's make sure I save everything. So I'm going to select C one more time. Okay. Compiler error. Okay. Place. What the heck did I do? Did I save it? Nope. Okay. All right. So now this part works. Slash view slash. Oh my goodness! Now I don't remember what I called it. Lecture 16 for Q1. And here's now our result that says that C was selected twice. All right, so now what do I actually care about all of this? What I cared about were these questions at the end. Yes, here. What makes this a framework? So when I say with this, I mean play, this machinery that you've been battling with the last 30 minutes. What makes it a framework is that it bundles up all the expertise that none of you have, namely how to write a web application. Right? Everyone said, oh, I have no idea what they're doing at this point. And that is really by design, because a web application is a confusing thing, right? It uses a protocol that, if you're a full stack web programmer, you know it by heart, but if you're an application programmer, I mean, how well do you really know HTTP? And do you really understand what does the web server do and all of that stuff? So it hides all of those details completely from you. Once you've mastered how to use Play and how to use this routing thing, then you can just code in Java and do all of your stuff in Java, all your business logic, all your database, all your everything. And you don't have to worry at all about how web stuff works. So it abstracts all of that away. Like, there is no main, obviously, right? There was no main anywhere in sight. The web server just keeps running. So thing that makes the framework characteristic is it provides superclasses, and you extend those for your own purpose. The class that you extended here was controller. Whatever a controller might have been, but you extended it, and that's how you smuggled in your own functionality. Now, some frameworks, they do everything with just extending, like Swing. In Swing, you extend, and that's really all you do. In JUnit, you have to use annotations. You have to use the add test. Play had a different way of achieving some configuration, that funny conf/routes file. That conf/routes file is actually written in Scala. You don't know that, but it is written in Scala, and it gets compiled behind your back. So that was their configuration. So is this an example of inversion of control? It totally is, right? Because you were not in control at all. You were notified when the user did one thing or did another thing. So Play actually, in 30 minutes, you got just enough out of it to be dangerous. And last semester, I had a bunch of people use it for their project, the ones who did the team UML thing. And this is 90% of what they needed. All they needed to be able to do is receive commands that something happened, and then someone else would send a command and say, hey, what just happened? That was on a different machine. And then the app would send something back. And so they put it on the server, and I gave them, thanks to Google, some free Google money to run it on the Google Cloud. And it really was super simple. All right, so that's where we're at here. Go ahead and send me your project requests by, as soon as possible. Thank you.